Hi everyone. In this video, let us talk about all the key pointers that you must have on your fingertips in order to solve almost any equation with respect to numerical solutions to equations. Why do we call it numerical solutions over algebraic solutions? Because if you look at some kind of equation like this, which you can't solve it directly to find the value of x, you need some alternate approach to solve it. I'll show you another example. If I ask you to find the value of a, do you think you can directly find it? The answer is no. So for this kind of equations which you can't directly solve and get the solution, in that case is what we do is we try to approach some kind of iterative techniques to get an approximate solution for the respective equation. Of course, you will learn a lot more iterative techniques other than what you're going to learn in your P3 mathematics in your university. There are methods like Newton-Raphson method, there is RK methods, and all of them are quite beautiful. If you are going to create some kind of simulations with the help of coding, numerical solutions is going to be your savior. But anyways, all of these kind of things you'll be learning in future. But yeah, that is the reason why we call it as a numerical solution, because step by step, iteratively, we get to an approximate value of the solution, not the exact value that we get with the help of algebraic method. If you get your solution directly with the help of some kind of algebraical technique, you call it algebraic solution. If you get answers with the help of iterative techniques, you can call it as a numerical solution. And that is why the chapter name is Numerical Solutions to Equations. Now, there are multiple things that you can keep in mind over here to understand the entire process, how the numerical solution works. The first thing to keep in mind is that we can use a graph to prove that root exists for a given domain. So I'm talking about a question like this over here. You are given x power of 5 is equals to 2 plus x. Now, graphically, if we are going to plot this, x power of 5, because it's having a odd number in the power, it's going to look something like this. And then 2 plus x is a straight line, which is going to look something like this. Now, with the help of this graph, I can clearly show that here is one solution. Now, another way to show that the root lies between the two values can be done with the help of a technique that I have mentioned over here called as change of sign. If you want to look into the example for the same, it is given over here. Verify by the calculation that the root lies between 2 and 3. So what do you do over here? In this case, you take entire equation on one side and call the other side as 0. So let's say if I keep a to the right side, it's going to become 4 minus square root of 2 sine half a minus a is equal to 0. Now on the left hand side, I can call it as a function of a. And on the right hand side, of course, it is equal to 0. Now, let's say if there is a root over here. Now, if I pass a value that is, let's say, to the left of the root and a value that is to the right side of the root, of course, you can see that there is a change in the sign of output. Before the root, it was positive. After the root, it is negative. It means that somewhere in between, it must have passed the x-axis, which is your solution. It could be like this also, okay? That to the left of the root, you are having a negative value. To the right side of the root, you are having a positive value. And then if you're going to plug these values and there is a change in the output, change in sign of the output, let's say someone is a negative sign and some value is a positive sign. So in between that, we confirm that there is a root present over there. But so far, we have just got a rough idea that root lies somewhere in the domain. But how do you find the exact value of the root, or I should say approximate value of the root through an iterative process? For that, you will have this kind of iterative formula, which you either have to convert it by yourself, and in some kind of questions, they will already be provided to you. But how do we use this kind of iterative formulas? You start with some kind of a value that makes most sense if it's not already provided to you in the question. Then you plug that in wherever the x is present and get the output in the calculation. Then put that output again as an input and get a new output. Keep on doing this until you see that the outputs are starting to converge. And if your outputs are going to converge, it means that you are getting towards an approximate solution to that particular equation. And that is the whole game that you're going to play in this chapter in your P3 mathematics. So yes, the first point is that you use the graph to prove that the root lies in a particular domain, but it does not tell you what is the exact root. The second one is to use the change of sign method to prove that the root lies between the two values. That is to make a function like this, put a value, the two values that are given to you, and if there is a change in the sign, one is positive, one is negative, it means that your root is present somewhere in between these values. But again, with these two methods, we are not proving that what is the approximate value of the root. So we find the approximate value of the solutions using the iterative process once we are having an iterative equation. I've also mentioned that rearranging a given equation into its iterative format is one of the type of question which can be asked in the paper. Over here, this is one example. This is the starting point. We have to convert this equation into its iterative format. And then we have to use the iterative process that is like, some initial value is given to you. And then you keep on entering it, get the output, and wait for your outputs to converge. And when your outputs converge, that value is approximate solution. But it's good to know that sometimes iterations may fail to converge. But yeah, those kind of scenarios you will be learning as you go ahead in your universities. But yeah, this is so far the idea about the numerical solutions. Now, sometimes this kind of equations are to be made with the help of calculus and sometimes with the help of circular measures that you've learned in your P1. There will be some kind of circles given. Maybe this kind of shaded region is there, and from here you will be trying to make this kind of iterative equation. Of course, this kind of things are different for different kind of questions, but the main idea is using certain kind of concepts, you will have to create this kind of formula when it is asked. And then eventually you'll be passing some kind of input value and then keep on doing the iterations until the values converge. So yeah, that is how we deal with the chapter numerical solutions to equations.